Welcome to Docker birthday number 3. There's a whole bunch of Docker birthday events, apparently around 120. Lots of RSVPs, and we've got lots of mentors helping us today. Actually, can the mentors in the room stick their hands up? Cool. So a big thank you to everybody that's mentoring today. And a whole bunch of partners. Throughout the day, you can tweet pictures, so you can see our lovely Docker birthday cake there. And if you tweet pictures with #DockerBirthday, Docker will pick them up. So we're going to start with a few slides about Docker and the Docker ecosystem. Then we've got the birthday app training. Then there's also a birthday app challenge and cake and socializing. So we're going to start with these slides on the Docker ecosystem. I think I'll try and get through these fairly quickly, because I guess most of you are roughly aware of what Docker is and what it does, right? Yeah, more or less. So anyway, so the word Docker itself is a little bit overloaded. It refers to two things. One side you've got the Docker project, which is like the Docker engine and so on, and you've got all the Docker images, but there's also Docker Inc., as in the company itself, who are now calling themselves a container as a service provider. We only came up with that the other month, but quite an interesting term. And so Docker Inc. are the primary sponsor for the Docker project and provide technical support and hosted platforms, etc. There's a very large Docker ecosystem. Lots of third-party companies providing products, etc. Here's a very interesting one. So DockerCon 16 in the US is in Seattle this summer. And they're actually doing a diversity scholarship program. So anybody from an underrepresented group can apply to attend DockerCon. And if you get your scholarship paid, you get a free DockerCon pass, plus the round-trip airfare and hotel accommodation. So it's definitely worth applying if you're from an underrepresented group. I believe you get to sort of say if you're from an underrepresented group. I don't think there's like an official list of what is an underrepresented group, but you have to go on the website to check that. So, Docker in 2013, so it started 3 years ago, and it was very much just the Docker engine. You can actually go online and you'll find like Solomon Hykes does a presentation to PyCon, I think it was, and that's kind of sort of considered the sort of starting point of Docker. So it started off with lightweight runtime with robust tooling to build and run virtual containers in Linux. So we had several sort of basic parts. The Docker image, which is used to create the running Docker containers. The Docker container is the actual running instance and the standard unit in which applications live. The Docker engine creates, ships and runs Docker containers with around virtual hosts or physical hosts in data centers or laptops or the cloud. And then there's the Docker registry, which stores Docker images that you can then pull and turn into containers. And the movement behind this is sort of about applications changing. So back in 2000, most applications were sort of monolithic in the sense that you had sort of large Java and C# applications that were, millions of lines of code, and they would run typically on 1 or 2 servers. And when you needed like scale up because you got more customers, whatever, what you did was you bought a bigger machine, right? You bought more memory and more CPU. But things have changed since then, and we've moved to this idea of like microservices, where we've got lots of loosely coupled services that are updated all the time and independently. And rather than running on large servers and scaling up by buying more memory and CPU, you buy more small servers and spread the load across them. But the problem is that's created what Docker calls the matrix from hell. So the thing is, you've got a bunch of different environments in which you need to run. So like developers' laptops, virtual machines and servers, you've got staging environment, you've got production environment, it might be on the cloud, etc. And you've got a bunch of different things you need to run in those environments, from workers, websites, front ends, RabbitMQ and stuff like that. And the problem is, whenever you move those services between environments, things tend to break. And the reason they break is because there's subtle differences between the environments, right? There might be a different version of a library, or it just a different config value or something. And the solution to that problem, or any solution, is to use Docker containers. And basically what they do is package up software, the binaries and dependencies down to the operating system level. Isolate software from each other, and containers form a standard format that can be easily ported between the environments. Yeah. And so developers, this is a very wordy slide, but developers like Docker because they can finally build once and have it work the same everywhere. And so it's no longer this problem, but it worked on my machine. Basically it provides a clean, safe, hygienic and portable runtime environment for your application. You don't have to worry about missing dependencies, packages, etc. Each app gets run in its own isolated container. So if you have multiple small applications, or you've got like an application using a database, typically you split those into separate containers. You can automate everything with containers and eliminate concerns about compatibility in different platforms, and it's much less overhead than VMs. Ops also like containers because they just have to worry about configuring it. And they don't have to worry about the software that's actually running inside it. So it makes the entire life cycle more efficient, consistent, and repeatable. Apparently it increases the quality of code produced by developers. I'm not quite sure I follow the logic there. Eliminates inconsistencies between development, test, production, and custom environments. Interestingly, it does support segregation of duties. So ops become responsible for taking these containers that developers have created and make sure they're running a network together, but they're less concerned about what's actually inside them. Significantly improves the speed and reliability of continuous deployment and continuous integration systems, and they're more lightweight so that you get better performance compared to VMs. If you compare containers and VMs, you get a diagram something like this. So, but basically in a VM, you need a full copy of the guest operating system on each VM. But with Docker, it's actually possible to share the guest operating system between applications. So that's one of the reasons that containers are more efficient. They don't have the overhead of the hypervisor. So on an operating system, the hypervisor has to interpret all the commands in the guest operating system and translate them to the host operating system. I guess this is this diagram showing what level 2 hypervisor. It's also level 1 where you wouldn't have the host operating system. Or I can't remember which one's level 1, which one's level 2. The difference though is a virtual machine. You could have a different operating system running in your guest operating system. So you could have Windows running on a Linux host, for example. You can't do that with Docker because Docker shares the kernel. So in Docker side, if you run a Linux host, all your containers have to be Linux containers. You can't have Windows containers running on Linux without a virtual machine in the middle. And that's kind of where the efficiency comes from, because you're able to share the operating system kernel. So Docker in 2016, they now describe themselves as a container as a service platform. I'm not a huge fan of the term, but basically I think what they're trying to say is they're not infrastructure as a service, and they're not quite platform as a service. So in platform as a service, you bring the code and they host it and run it and figure it all out for you. They're more low level than that, but they're higher level than you provision machines and do everything. So what you do is you create your containers, and then Docker tools will take your containers and run them for you. So this is what the platform roughly looks like. You've got Docker in the middle there, and they're providing management, security, orchestration, the runtime, the registry, etc. Everything you need for running containers in production. There's two main solutions we're offering. The Docker Data Center, which is the on-premise version, and this is the paid stuff. So like the Docker core engine is like free and open source. The Docker Data Center and Docker Cloud are their paid offerings. So Docker's Data Center is an on-premise platform that integrates with enterprise infrastructure. The Docker Cloud is like their hosted thing that runs on AWS, and you log in and provides you a nice UI to manage your containers. Let's get that. Right, the interesting bit. So the birth of the application training, I'll go through the rest of these slides and we'll come back here. You need to use a Docker toolbox, especially if you're in Mac or Windows. Does anybody have a Linux machine? Yay! So you don't need a Docker toolbox, you can just apt-get or whatever. But anybody else needs a Docker toolbox which will install a VM which will run Linux and you run your containers on Linux. The toolbox is made up of a bunch of stuff. Pragmatic, which is a nice little GUI for running stuff. Docker CLI, Docker machine. Docker machine provisions your virtual machines for you. Docker Swarm, which does clustering, so you can set up multiple VMs and load balance your containers across them. And Docker Compose, which is the orchestration layer. At the birthday app training, basically what we're going to do is create a simple voting app, but it's made up of a bunch of different containers. And if you use it to show how you can use different technologies together, we've used a bunch of different tools. So there's a Python web app talking to a Redis queue, and then you've got a Java worker, and a Postgres database, and a Node.js web app. And hopefully it all work nicely together. You can actually grab all the training materials yourself. It's at this URL, github.com/docker/dockerbirthday3. So there's two bits to the tutorial. There's a self-paced beginner's tutorial, and I think there's a more experienced, I'm sure there is 2 bits to the tutorial. After that, there's also a birthday app challenge, where you can basically work on whatever you like. There is a couple of suggestions here, but if you do something interesting, you can submit it to Docker and potentially win a bunch of swag and a complimentary pass to DockerCon. I'm assuming that's DockerCon in the States. And you can also win a hoodie. Okay, so on to training. It's self-paced. Basically what's going to happen is just go to this URL, start working through it. If you get stuck at all, just stick your hand up and one of us will come and help you. Actually, before we do that, because the mentors want to stick their hands up again. So yeah, have a look around. I've got loads of mentors. Cool. Yeah, so if you stick your hand up, somebody will come along pretty quick. Right. Good luck.